This is not just another Microsoft Fabric video. This is Microsoft Fabric for those who know nothing about Fabric. At the end of this video, I'm going to show you how easy it is to get started with Microsoft Fabric. I'll walk you through a practical use case that exposes you to the different elements, components, and workloads in Microsoft Fabric. And of course, at the end, I will share with you amazing resources to help you get started. Without wasting time, let's get to work. Just before we start, you need a Microsoft Fabric enabled tenant and license. In case you don't know how to go about this resource will help you. You can set up a Microsoft 365 developer account and also enabled Fabric for your tenant so that we can be on the same page and you can follow along with everything. Back to the use case. We're going to source our data from Kaggle using Microsoft Fabric Notebook. After that, we're going to push the data to Lakehouse. And while the data is in Lakehouse, we will explore the data using the SQL Visual Query and, of course, build a Power BI report from the data. I believe this is going to be a spectacular experience for you. So let's get started. First, the data. This is a fictitious data that was designed to predict the monthly revenue of a restaurant. Okay, so I won't go into the details, but the link is also in the video description. You can go through it and learn more about the data. So we're going to be downloading this data. Instead of you downloading it manually, we will do everything in our Fabric notebook. We're going to connect to this data directly from notebook and download it right from there and not from here. And that will expose you to learn something interesting, right? Also, to get this done, you need to have your Kaggle API key. Yeah, this is very important because you're connected to an API to download this data. How can you get your Kaggle API key? So log in. I'm logged into Kaggle right now. You create an account, then you go to right here, you go to settings. From settings, you'll be able to see your key. Right there. Under API, you can see you create a new token. This will download a JSON file on your system. Open the JSON file and you will see your key. You copy the key. I will be using my key in Fabric Notebook and you will see how it works. All right. Now that we have all the prerequisites, you've set up a Microsoft 365 developer account, or you already have one, or you have, maybe Fabric in your tenant and you have license to use it. So you're fine. You're good to go. And now we've seen the data we'll also be using, which is restaurant data. We've also seen how to get your API, which you will be leveraging within Microsoft Fabric Notebook. Let's go back to Fabric, set up a workspace, and get started. Back to Microsoft Fabric, app.fabric.microsoft.com, and that takes you to Microsoft Fabric. Let's create our workspace. I'm going to click on the left here, workspaces, and create new workspace. I'm going to call this Fabric Demo. It's available, and come over to advanced and you can assign a trial license. This is very important. You need a trial license to experience Fabric. I'm going to click on apply. This is going to create a fresh new workspace where there's no resource, there's nothing there. And at the bottom left here, you might start with Power BI, you might start with any of those workload, but this just to show you the different workloads that we have in Microsoft Fabric. If I click on this Microsoft Fabric, you can see them, Power BI, Data Factory, Activator, Synapse Data Engineering, and all of this. Don't forget, we want to connect to our data wherever it's stored, which is actually on Kaggle, and extract the data and do all the kind of manipulation we like to do, store it, visualize, and interact with this data. You can actually click on the Synapse data engineering workload because this is the beginning of the journey. We need to connect to our data and extract. You might as well want to do everything from your workspace, which is Fabric Demo. So I'm back to the workspace, which is empty right now, and I can create, this time around, I'm going to create a lakehouse because that is the beginning. This is where you want to drop your data. So lakehouse, I'm going to title this Fabric Demo Lake. Fabric Demo Lake. Right. We're going to create a lakehouse. Lakehouse is where you drop your data, just like the lake, where you drop everything that you are building, your data, wherever it's coming from, you drop them in lakehouse. So we've created something, and Lakehouse is very powerful because it can take both structured data and unstructured data. So it combines the analytical of data warehouse as well as the power of Azure Data Lake Storage, which is the ADLS, as well as the computing power of Apache. So everything is really right there. To get our data into Lakehouse, you can use any of these options. New data flow gen 2, which just is a visual guide that enables you to connect your data and just extract it and load it into Lakehouse. And we also have pipeline, which is a series of orchestration where you can set a lot of processes and activity you need to do to get your data into your destination. But we're going to be doing this through Notebook. Yeah. Why? Because Notebook is more powerful than all of this. In case you are working with heavy big data, Notebook allows you to do a lot of customization and transformation because of our purchase pack within that space. So we will do Notebook, even though our data is very few, but we're still going to use Notebook. So right here, I have Notebook. I'm going to create a new notebook, open, and because it's connected directly to the lakehouse, so it knows that this notebook is stored or is part of the element access and accessories in the lakehouse. You see, it has connected directly to the lakehouse, Fabric Demo Lake, and there's nothing here, nothing. I can save my notebook and rename it right here and just call it Kaggle. So this is the notebook that I'm going to use to extract my data from Kaggle. Another thing you need to do is to install Kaggle library. And how do you know if Kaggle library comes with it or not? Let's just write a series of code, and I'm going to paste the code right here so that to make everything fast for us. And let's run it to know if API, the Kaggle API is already there or not. The Kaggle API library. When I run this, while I'm running this, it's going to start up a session, a Spark session quickly because there's already a compute engine machine that is set up automatically that just gets spin up anytime you are starting a notebook activity, which is Apache Spark activity. You can see a session has been started, but there's no module name Kaggle. So that means we literally have to install this. There are many ways to install library in Fabric environment. I'm just going to use inline one where you use this asterisk pip install, pip install Kaggle. I'm going to run it. Shift enter, control enter, all of them will do the work. They will install Kaggle. As you can see, installing and successfully installed Kaggle. Right, we are done and we are sure right now that that library will open and work for us. Traditionally, when connecting to Kaggle API, you need to store the key that you have observed in a folder on your operating system, on your system, locally somewhere. But because we are within a cloud environment, we don't have access to that place. So we need to do some things here. So I'm going to literally copy and paste some set of code here, which is easy to follow, and I will explain that right now. Import OS means we are just trying to import the operating system, which is already there in the cloud because we want to make some changes, and I'm setting a directory. The reason why I'm setting this directory, I'm just going to set the files. Let's make a directory files, meaning here, this directory, if I click here and I say copy ABS file format, let me paste it here so that you can see what that means. This is the absolute format. But if you click here again and say copy the relative path for Spark and paste, it's just files. And we click back here and say copy the file API path, which is exactly what we need. I'm just going to paste this here. You can see that is exactly what we have here. All right, so that's how we get that, not something to cram. You can always come here and copy any of those five parts. But I'm setting my directory. I'm changing directory to this particular place, saying that, oh, this is where I want you to reference. Anytime I download something, I want to access default directory, change it to this place, irrespective of wherever it's pointing to before. That way you can control where whatever you are downloading is being stored. And for me, I have changed my directory. And of course, you need to set up this variable within the environment. The Kaggle username, this is my username for my account. This is the key. I will change this key after that. So when you download the create token on Kaggle, you will use this key to authenticate. So the key must be there before you can import. If you try to import Kaggle API without setting this, it will not work because it cannot find the API key to authenticate. And right now we're instantiating a Kaggle API connection, and here is the data. Here is the account where the data is stored. This guy is right here. So I'm going to come back here so that you can see this is it. This is the account. That is it. On that Kaggle, this is where I get that. After data set, this is the account where the data set is stored. And that's what we have right here. And the name of the file, this is it. This is the name of the file. How do you locate the name of the file? The name of the file is right here. You can just right click and copy or just highlight just to copy the name of the file. And that's all I did right there. So let's run this and see. I'm going to run this now. It's going to instantiate, try to see if there's a connection. And if there is, it's true. And true means I have executed all these lines of code, including even downloading the data. So if I go back and click on this file or just refresh, you will see under this file, we're going to have a data now, which is a CSV file, and that is it. It has downloaded the CSV file. This is the CSV file. Now that the CSV file is downloaded, we need to then load it. And over time, we can start doing our manipulation. So it's downloaded, but we've not loaded it into this environment where we can now start manipulating. So how do we do that? We use Python. You can write different flavor. We are writing Python now. You can do Scalar, you can do Spark SQL, you can do R. And all of this you can do that within this notebook. So what do we need to do? You import pandas as PD. Panda is a library in Python used for data manipulation. And what are we then doing? Where we need to read the file, the CSV file. Where is the file stored? It is stored inside default. Yep, I'm going to change this. Don't forget where the file is stored. Lakehouse default. And then this is Lakehouse default. Everything we have here. And I'm just appending that this is the source where the data is. Okay, always use this. And I'm also asking, give me the head. Head is top 5 of the data. After reading it into Panda DF, then give me the head. So I'm going to run this. If it works, you're going to see the result. Amazing. So it's saying, oh, this is the top 5 for this data. But because we have loaded this data into data frame, we can now start doing manipulation. There are quite 3 things we want to do. From this data is not complex. So, but we want to do 3 things quickly. Number 1, we want to break this data into fat and dimension. Not so complex, but just to show you little things here before we even load it to table. We break it to fat and dimension. What are the fat value here? All these numerics are fat, and dimensions are categorical data here. For example, cuisine type is categorical. We're going to extract it. We're going to create a dimension table for it. And also promotion right here. Yeah, it could change. The value could change. They could increase the value, the category. So I'm going to take promotion also as a dimension and extract it and rename it and do a couple of things right here so that we can just build something little, not just little, but great. Okay. So what's the next thing? I'm going to show you now what we call Data Wrangler. Data Wrangler is a visual tool in Microsoft Fabric that enables you to actually work with your data without writing code. It can interpret your set of actions into code and write the code for you. But you just click, drag and drop to do whatever you want to do. And how do we, interpret this? When you have loaded your data into Spark data frame or Pandas data frame, that is when you can use Data Wrangler. Otherwise, it will not be activated for you. Now that we have at least one data frame, which is Panda data frame, if I go to the data menu right here, you will see transform data frame in Data Wrangler. It is not transform data, transform data frame. So your data must have been in one form of data frame or the other. The moment you click on that button, start loading to just evaluate what are the data frame that I have in this whole notebook. And what we have is DF, which is the pandas data frame. There's no Spark data frame right now. That is why nothing is shown. So we have DF, which is the pandas data frame. Let's click on it, and that shows us exactly what we have right here. Let's extract a dimension table for cuisine type. And what does that mean? It means by first dropping duplicate. So I can come over here and say, look here, under schema, you can see change column. You can see so many things you can do right here. I can select columns because I just need a single column. So I'm going to click on select column. What column do I need there? I need my cuisine type. So this is the only, cuisine type is the only column that I need right here. Select column, then click on apply. So in this way, it's going to select only cuisine type. Yes, and that's not all. You see, I also want to drop duplicate because it has selected real time. That change is taking place. The Python code is being written here and it's taking place. So I'm going to go back now and look for another one that will help me drop duplicate because I need to drop duplicate from this. So when you come over to formula, you can play with all these things just to see, oh, what is there? Drop duplicate rows. You can see drop duplicate rows. When I click on drop duplicate rows, and cuisine type is what I need, that's what I need, then click on apply. When I click on apply, you see we only have unique value for the cuisine type. Japanese, Italian, American, and Mexican. This is the index. Of course, we need to reset the index later, but this is it. Now, what do I need to do? I just need to go back and say add to notebook. When I click add to notebook, it automatically transfers the code to my Jupyter notebook. So I don't need to even write this code. In case you don't know how to write Python, this is magical, like automagic, automatic and magical. So right there, I have this. Okay, good to go, right? Okay, so I am going to just, instead of click add, I don't need the add right now. I'm just going to say, load this into df underscore clean. So let me run it by pressing Shift Enter or using the button here or Control Enter key. So it has actually done that. I need to do few other things, which includes resetting my index. So I need to reset index. If you're wondering what does that mean, so first let us check what is in this table. So df underscore clean dot head, so that you see what is in the table. This is it. Okay, zero here meaning no, not zero. I just need head. I'm gonna see. You see, this is cuisine type, but you can see the value here is index 0, 1, 5, 10 is not accurate. So we need to reset the index, and that's why I'll be using this df underscore clean dot reset index. I'm dropping the index and I'm replacing it. So when I do that, that works. Amazing. So how do you know? When I run this again, you observe that it's no longer 0 to 0, 5 something, it's now 0, 1, 2, 3. So it is properly indexed. Okay. After we're done dropping index, I need to create a new column. Remember, I'm creating my dimension. This is my dimension table. I need to create a new column that has cuisine type ID as well. So I'm going to just use this to do that. Cuisine type ID, I'm taking the count from 0 to 4. So 0 to 4. That's what I'm doing. Start from 0 to the length of that row, how many rows you have there, and then use that to create a new ID for me. When I do that, right there, good to go. If you want to see, we can still go back and run this again just to see what do we have now on the data frame. We now have this data frame. It looks like, wow, we have the same numbers. This guy is indexed, while what we have is the cuisine type, so it's the additional column. And you can use this column. The goal is to go back to this primary table and remove cuisine type, which is the name, and replace it with number, because we're trying to match them and say part and dimension table. Okay, so now that we have this, we can easily call this our dimension table. We're going to rename it as dimension table. The next task is to actually create our fat table. That original table is just the raw data. So I'm going to use this to create our fat table. Fat table, which is, I'm just going to call this fat. I'm using df.merge to actually merge them. I'm merging the df table with the df clean, and I'm using cuisine type because that is the same unique ID. Not ID, is cuisine type. That's what is common between these two tables, cuisine type, and I'm using that to merge them. And I'm doing a left join so that everything towards this table is being added to what we have on this table. I'm just keeping everything on the original table here. Okay, so when we do that, and we're doing this together. So let's see. Now we are done. Let's say fat dot head. Let's check the head. Amazing. Yep, we have fat dot head now, and you can see cuisine type ID is now on this table, but we still have cuisine type. So we need to drop this. You can tell exactly what we need to do right here. What do? We go back to Data Wrangler, and within Data Wrangler, you see we now have the fat. So I'm going to go to fat, and all I need to do right here in fat is to drop column. So I'm going to drop column, and what column am I dropping here? So you check this under schema, you see drop column. I'm only dropping the cuisine type because I already have the ID now. So I'm going to come back here and say cuisine type, I'm dropping you. Okay, this is going to run, and I'm going to click on apply. So this is dropping cuisine type. Okay, and let's say add to notebook. When I add that to notebook, we're going to see right there, cuisine type is going to be dropped, and fat clean. Let's keep it as fat. Yeah, override the original table. Yep, fat, good. And I'm going to run this. So we don't have cuisine type again with our cuisine type ID. So we have our fat table. And don't forget that we already have our dimension table for cuisine type, which is df underscore clean. We can always rename that later, but we don't even need to do that. Let's continue. So the other thing we have to do is the promotion. I told you about promotion. Promotions is here. So we don't really need to join or merge because promotion is just 0 and 1. So let's go back again and generate our promotions table from this. Wow, that looks somehow right. We go to our data wrangler. You can use either the df or the fat because all we just need is promotions, right? Okay, so I'm going to go to fat and extract, remove all columns, drop all columns and keep only promotion. Exactly. So first thing is to drop columns. So we're going to come back here and say drop columns. And what columns are we dropping? We are dropping all columns except promotion. Select all and unselect promotions. So I've selected all and unselect promotion. That way it's going to drop all of them and only leave promotion. Click apply. Yep. When I click apply, you see this will work now and we only have promotion. But if you pay attention, we have promotions, but the values are repeated because they are still duplicate. It only remove all columns and did not remove the duplicate rows. So to do that, come back here under find and replace and go to drop duplicate rows. And of course, we only have one column here. So it's just going to select it and drop duplicate rows. Apply. Good. And it's going to apply that. And you see, we only have two rows for promotions, which is 0 and 1. 0 means no promotion, and 1 means there's promotion, meaning was that cuisine, was that activity promoted or not. So no, we didn't pay any money to promote it, and we pay to promote. That's what that means. Paid promotion or no promotion. So let's go back and say add to notebook. This is going to be our dimension table for promotions. So we have it right here. Instead of fat underscore clean, I'm just going to call it prom. Call this prom and also rename this as prom. Good, right? Okay, so let's run this as well. We have the from table now, and it's just 0 and 1. Let's add a column to tell us what 0 means and what 1 means, right? So on our prompt table, we're going to add a column that will tell us what 0 means and what 1 means. So this time around, I'm going to just use this line of code to do that. So since our table is prom, I'm just going to say prom. Yep. Oh, we've dropped duplicates, by the way. So all I need is to use this column. So what I'm going to do is to use this code to do that. From promotion name, we're adding a new column to this prompt table, and I'm just going to call it promotions. I'm mapping 0 to no promotion and 1 to promotion. That's what it means right here on that same table. Okay, so let's run this and let's check the head to know what is happening there. From dot head. So it's going to run it. Hooray, we have it right now. We have our promotions, and we don't need to link this back to the original table, right? Good. If you look at it, we've done three things here. Number one, we've been able to generate our dimension table for cuisine type, which is the fat, which is actually df clean. Yeah, that is our dimension table for cuisine type, is the df clean. This is it. We've gotten our fat table now that has only number. If I go back to fat.add, fat.add, we should not see, we should have only numbers, which is the way fat table should be. Only contain your continuous value variables and numbers, while the categorical values are stored somewhere else. And for the dimension for promotions, we already have this small table. That's two columns. That is the dimension. So we have these three table now. One is fat and two dimension. We've not loaded them yet into tables. This is the data format, and we're going to load it. We can load it with Python or use Spark. And I will use this also to introduce you to Spark, using Spark to load your data into tables. So we're going to load them one after the other. So it's time to load, but before we load, we need to convert them to Spark data frame. All the three, we convert them to Spark data frame. See what it means. First, Spark df, let's make this our cuisine type. So Spark df cuisine, you can just call this Spark df for our cuisine. And we are creating this command spark dot create data frame, which is, and the value we are using is df underscore clean. That's df underscore clean is our cousin type. So we are using that pandas data frame to create a Spark data frame. I'm going to run this line of codes now. Amazing. So do you see the reason why I use this display to actually run this is so that you can see how display works. Within Notebook, if you use display to show your result or show a glimpse of your table, you can actually visualize it. For example, if I click on chart, you can see right within Notebook, you can do this. And you can even toggle what the chart should look like in case you have multiple columns there and select the columns you want to use to plot your analysis. So to visualize right within Notebook and have a glimpse of your data. That's amazing, right? I decided to also show you that part. So now that we've converted this to a Spark notebook, a Spark data frame, let's do the same thing for others. So I'm also going to just copy this. I don't need to visualize others. I'm going to copy this. Instead of this, I'm going to say Spark df fat for my facts table. And what do we call the facts table? Is actually fat, right? Yes, we call it fat. So let's go ahead and change this guy to fat. Okay, so we have this and it's fat. So I'm going to do the same thing for our promotion, which is prom. So I'm going to, instead of fat, I'm going to call this prom. So we also have our prom. All right, what I'm doing here, okay, so right here, we've been able to convert our fat table now, pandas data frame to Spark data frame. And here, the dimension table, which is the prom, we've been able to also convert it here to Spark data frame from pandas to Spark. Right. So the reason why I just want to show you how easy it is to switch from one form to another within the same notebook. And when your data is big in terms of variety, volume, and all those things that make up a big data, you will find this really helpful because and it's easy to interchange and use them within notebook. Now that we have all our three data frame, all the three data frame, we have them. Let me just um, hide this output. We have all the three data frame, which is the cousin type. The cousin type is our dimension. The fact, this is the fact, this is another dimension. So now let's create them as a data table right there so that we can create a relationship from them. What we've just done is we've extract, we've loaded, we are transforming. It is not extract, transform, and load because we actually extracted and loaded into files before we even start doing this manipulation and also loading it again to a table format. Amazing, amazing concept. And this is really interesting, right? So now I'm going to use this line of code to actually create my table. And I'm going to say Spark df because I'm going to start them one by one. This is Spark df cuisine, Spark df cuisine because that is the first one. Yep. I want to save this as my dimension cuisine. So um, using the command write dot format as a data table, which is going to be under a table, overwrite in case there's already existing table, save as table, and this is the name of the table. I'm going to call this dim what cuisine type. Here you can see why we've not named it the other time. Now we can actually name the name of give the table the exact name we want the table to have. In some scenario, you need to define the schema of this table so that and that becomes faster. It will load the data faster whenever you define the schema and then load data into the schema. But if you do not define schema means you are specifying the columns and the data type for each of those columns before you load data there. But if you do not define them, it's going to create automatically and load the data, but that won't be fast. You won't notice it here because really the data is not much. But if you are working with huge volume of data, you might observe the differences. So let's also copy these and yeah, run it for all the three that we have. So we have our first, which is cousin dimension cousin type. Let's go for another dimension, which is spark df prom, spark df, and just call this prom because that's the Spark data frame. Remember, we are converting Spark data frame now to, we are converting our Spark data frames now to a table, data table, and not the Python data frame. I'm doing this just to show you how to switch from Python to Spark and still continue your work from there. This time around, it's going to be dimension promotions rather than just cuisine type promotions. And lastly, this guy is going to be for fat, df fat. So what do we call it? Yeah, Spark there fat, and we're going to call this fat restaurant. Okay, let's just call it fat restaurant. Yeah, okay. So I'm going to load this three. Observe, it's going to take some seconds. It shouldn't be that long, but all of this is going to create table here. There's no table here for now, but after this is done, we're going to have tables, 3 tables that we can then start working with. 20 Spark jobs. If you click here, you're going to see, you might not understand this, and you don't even need to understand this right now, but it just shows you that it has parallelized the work, meaning it has sent it to several compute engine so that can be faster. It distributed the work, and that's the advantage of using Spark. Rather than just one single computer doing the work, it distributed among the workers. You do this, and they're able to do it faster, and everything is done. So all the tables are here, but we can't see anything. Let's refresh. So when you come over here and click refresh, you're going to see all the tables. They are data tables, and you see, amazing. We have the dim, which is dimension for cuisine type. We have the dimension for promotions. We have that fat restaurant. What we're going to do next is to go back to our Lakehouse, because this is notebook that is connected to a Lakehouse. That doesn't mean you are in your Lakehouse right now. So we're going to go back to our Lakehouse, and from there, we will use SQL endpoint and start interacting with this data with SQL. And we can also create this data manipulation we've done now. We can do the same thing within SQL. All right. Just before we do that, let me load the data, the original data that we have, which is the DF. Remember, we have a data called DF. Let's load this as well as a table and call it DF raw so that we can manipulate it with SQL. You should be able to walk through this process. Remember, it's DF and it's already in Pandas data frame. What we need to do is just to convert it to Spark. So I'm going to say Spark DF. That's original Spark DF. All right, we're going to write this code together, which is equals to what? Spark dot create data frame. And what are we passing there? We're just passing df. That's it. Df. We're going to run it. Let's do a view of that. So I'm going to say display what? Spark df. Spark df. I'm going to convert it to Spark data frame and show us. This one has a lot of data. And if I click on this visualize, you're going to see. And I can toggle this. Remember what I was saying the other time? Cuisine type by numbers. That's what we have here. You might just want to do another thing, cuisine or promotion. You can say promotions, for example, the promotion, and remove cuisine type and say apply. See, this is promotion, promoted more than non-promoted in terms of sales. So promotion is working. All these are just sums, this aggregation, just visual to help you. But we have it in a Spark DF right now. So let's save it as a table. And that would be Spark DF. I want to write this so that we write that together. We've been using the code just to make it easier. But now let's just see how easy it is. Spark DF dot, we're going to write dot what? Format. What format are we writing this? Is a data table format. And what mode? The mode is override. In case there's already a table like that, just overwrite it. And then over here, we're going to tell it to save it as a table. So we're going to have save as table. You can see the intelligence that is also there, IntelliSense that is helping you to navigate. This time around, I'm going to call this raw. Yeah, says raw. So that's the says raw underscore. You can just put an underscore there, says raw. Okay, let's run this. Create a table. So this is the table we'll be manipulating within SQL endpoint. It's done, it's fast. And if I refresh my table, you're going to see that right there we have the says underscore raw. Okay, so I'm going to switch back now to my fabric demo with my lakehouse. Or you can navigate back to your workspace. Within your workspace, you see that there are many elements now. You have the lakehouse that we've created. The lakehouse comes with two things. First, semantic model. That's the default model for all the data set you have there. And you also have the SQL analytics endpoint. That's what we need. This is the notebook that we have created. Everything inside the workspace. Right. Okay. But what we need right now is to go back to the lakehouse, which is the same thing that I've opened right here. So these are lakehouse. And within this little lakehouse, we now have all these four elements to start interacting with. And of course, we still have our files. Remember, we loaded that files here. So I'm going to refresh so that this can catch up. Yeah, this is the file, the CSV. Now we're going to switch here at the top right between Lakehouse to SQL Analytics Endpoint. And this is where we can start writing SQL query against the same data that we have. It took quite some seconds trying to load in case you did not refresh because I've left the Lakehouse for some time. So it didn't load, but now it has loaded and refreshed and realized that, oh, you already have 4 tables in your Lakehouse. And that's what we have here. And you can start writing your query. You can see new SQL query, new visual query, new report, even new measures. And we have the data side of it, of our SQL endpoint. We have the query side of SQL endpoint, and we have the model side of SQL endpoint, where we can actually model these tables. These are tables, but we want to create views and few other things right here. So I'll navigate back to my data view and create, and first, let's go to new visual query. New visual query is the UI UX that won't allow you, just similar to Data Wrangler, point and click within Fabric Notebook. Here is another point and click within the SQL endpoint. So when I say visual query, I need to drag in a table. And let's use our raw because there's so many data columns on it. I'm going to drag in my raw sys underscore raw table. Now we have our table. All the columns are on this table. And we might want to just do let's see how the visual really help. Very easy to use. E.g., I can come to transform and say I want to group by. As we are doing that, is interpreting your action to query. Oh, I want to group by what? I want to group cuisine type, and I want to count numbers of maybe some for what? Some for number of customers. I'm just going to call this customer count. Oh, as simple as this is, it's amazing. Rather, I just put it there, I just select what I need, and right here it has interpreted the query for me. Say, oh, this is it, Italian, these are the cuisine type, and this is the customer count. Isn't this amazing? You can actually view the SQL that generates this. As you are doing your transformation, is adding visual. You don't need to actually code doing this, and it's interpreting it. But if I click on View SQL, you're going to see the SQL that you should have written, T-SQL that should have written to get this result. But you don't have to do that again. But you might edit. In case you want to edit, you can edit it, but you don't have to. You can save this table as view, you can save as table, you can do all those things. All right. This is just to show you how easy it is to use this visual query within the SQL endpoint of Microsoft Fabric Lakehouse. Now, let us save this. I'm just going to save this by right clicking and say rename and say cuisine. Yeah, I'm just going to call this cuisine type. Yep, rename. So this is just going to save it under my queries because it's a query. It's just that you use visual mode to generate this query. That's it. Anytime you need it, you click on it, it's going to generate it for you. You can download the file as Excel. You can also visualize the result. Cool. Not so much, right? Now let's go ahead and write our SQL so that we can replicate exactly what was done before in Fabric Notebook. I'm going to do that by clicking on New SQL Query this time around. I will be pasting the query so that we do not take too much time here, but I'll be running it and I will explain every lines of the code. First, we're going to create a view for cuisine type. I don't want to create them as a table again. Remember, we already have our table here, so there's no need to start creating them again as tables. So I'm going to create my cuisine type. Just the same we have cuisine type dimension, but let's save this as view. View are dummy tables. They try to mimic table. They look like table, but they're actually created from tables. What I'm doing right there is to use window function to create auto numbering. That number of 0, 1, 2, 3 that I'm trying to create, which is the number I'm giving to cuisine type. That's exactly what I'm doing right here. I'm going to call it dim. Let's add the v to it, show that is a view. And rather than taking that from Kaggle, I'm going to take it from sys raw, sys underscore raw. Okay, so this is sys raw. We will be fine now. So let's run this and even see the result. So when I run this, click on this run button and select this query. You see, this is exactly what we want. We want cuisine type ID. This guy is even numbering for 1, 2, 3, 4. And we have the cuisine type. Cool for us, right? Now that we have this, you can actually save this result as view with this button here. You can save the result as view, and I can click on this save as view. I'm just going to grab the name here because that's exactly what I want to name it and put the name here. V means view dim cuisine type. So I'm going to click on OK. and it's going to save it as view. It has been saved as view, and you can see them under this view. But if you don't see them, just you can see view created. I'm just going to right click here or just select here and refresh. That way you're going to see the view. So we have the view, which look like table. We're going to explore it soon. For promotions dimension table, we're going to select promotions column from our initial table, which is says underscore raw, and then create a new column called promotion name and name 0, rename 0 for no promotion, rename 1 for promotion. Okay, so I'm going to run this query, and let's see what we get as result. We're going to get two rows, promotion 0 and 1, and this is what it means. And of course, let's save it as view. I'm going to copy this name as well and put it here, but let's use V. V means view, and I'm going to click on OK. That way, that view will also be created. You get the prompt right there that, oh, the view has been created. And for the last one, because the raw data, we just need to drop some columns on the, so on the raw data, I'm going to join my cuisine type to the fact table. I'm creating my fact table here, and I'm going to join cuisine type to the original table and drop a column because I'm selecting only the columns I need. So I'm going to select all these columns and remove my cuisine type because I only need cuisine type ID, which can be found already on my dimension table. So this is says raw and not Kaggle. So just make sure you follow the script. And this is all I have here. So let's run this. View. This guy is view, and it is not dim cuisine type. I've renamed it to view to just say view. So when we run this, let's see what we get. So we're going to have the original table, but without the cuisine type, which has categories. But this time around, there's going to be cuisine type ID, which is the number, just similar to what we did in Python. Now that I have this, I'm just going to click on Save as View, and right here, I will, fat table. Let's just say this is fat restaurant. So this is fat for restaurant. Click on OK, and that view will be created. Now that the views are created, we have all the views right there. The third one is going to populate here just now, which is the fat table. We have dimension, we have fat. Okay, good. In the modeling tab, you can see we have much more, a lot of assets now, both views, both tables to start interacting with. But we're going to create a new, come here and create a new report. If you also want to create measure, this is where to do that. So we'll rather go and create a new semantic model. Let's even create a new semantic model. We'll go back to our Lakehouse instead of using the SQL Analytics endpoint. Go back to Lakehouse and create new semantic model. For me to get this done, all I just need is to click on it. Clicking on semantic model is going to ask me what do I want to call the model. So I will call it restaurant 1. I'm going to call it restaurant 1 is within this workspace fabric demo. And what are the tables that I need? I might not need all tables. So in my semantic model, I need just the tables. And you can also specify the views if you want to show views, but I need tables. And what are the tables? Right there, I need my dim promotions, fat restaurant, and dim cuisine type. I'm going to click on confirm. So it's going to create a semantic model that only have those 3 tables. And there I can model the relationship across these 3 tables. Amazing. As you can see, I have the 3 tables. Of course, the star schema. This is just a simple demonstration. We have the 2 dimensions and we have 1 fat. So what is linking the dim cuisine type to restaurant is my ID. So I can drag this ID and place it on the cuisine ID to establish a relationship, between them. And the type of relationship from the cuisine type here is going to be 1 to many. So rather than many to 1, be careful, it is 1 to many because this table is distinct, but here we have multiple rows and multiple records. There's duplicate on this one. So it's going to be from 1 to many. And single, I'm going to click on OK. That will establish this relationship between them, right? From here, 1 to many. Star means many, here means 1. And for promotions, I'm also going to use the promotions and drag from here to this table is also 1 to many, not many to 1. So I have 1 to many, then here I'm going to click on OK. So what we've basically done is we've established relationship. And from here, you can do few other things, do calculation group, amazing, or do new measure. New measure could be we want to calculate the sum of monthly revenue, average, but these things are already calculated. But let's just create one measure so that we have measure to use. Otherwise, we can use implicit measure directly from here. Implicit measures are measures that have been created, like this sum, like this marketing spend, like all of these, they are implicit measure. If you want to create explicit by creating your own measure, you can do that by just clicking here. Let's call this total average spend, total average customer spend, cost, which is already there, but just to show you, we're going to call this, let's just use the sum. Oops. Coming back here. So let's just call this total average cost spent. It's going to be sum. I'm summing my average customer, which is average customer spending from the fat restaurant table. I'm going to close it just so that we have a explicit measure here. Closed. Amazing. Good. So we've created a measure. You can see that now we have a measure. It's created under this type, doesn't matter where it's drop it. You can always change it. Under our model, you can see the measures we have is one. Relationships we have here, two. You can see tables that we have there, three, and every other thing here you can see the extended tables, which are three. So this is where you see all your model, the element that makes up your semantic model, which is calculation group, the culture, the measures, the perspective, the relationship, the roles you have assigned, and that's where you can do your security and role level access controls and all those stuffs right there. So we have this. The next is to actually build our Power BI report. I'm going to click on new report to finish up what we've started, and this will launch Power BI. You can see how we integrated all this workload within Fabric, from ingesting data, cleaning it, making it available for data analysts and scientists, and right now building our report. And to do that, it's easy. I'm going to go to my FAT and just click on some measures here. This by cuisine type and also promotion or no promotion. I'm going to do that by cuisine type. Okay, so we have this by cuisine type. Good. I can change the directions of this. I can do my value label just to make sure that I know what is happening there. I can see the values are right there. Okay, so value data label to put it that into perspective and check sum of average. Yep, it's fine. I can also do similar thing for my customer spend, how much a customer spending for this different cuisine type, and put that right there. So this is fine. And then sum is fine. My data label, I can switch on the data label to on top of this. I might also want to display the total, spend, not as chart, but as value. So this is the spend, and this value I can, yeah, this is 20. Yeah, so this value is 29.48, which I might also want to, I can actually change how it appear, but I'm not going to change that. So let's just put this like this, all right? And do similar thing for any of these things, menu price, average menu price, and then say menu price, which I'm going to click on this guy, that's average menu price. This is sum, actually, we need average, but right here, it's sum. So I'm going to come over here and choose average. So it's going to get average of the average, which is $30.22, of course. All right. So you can go ahead and customize this and fit your needs. But this is how easy it is for us to go end to end. And I believe this is truly a spectacular experience for you. I hope you can see how interesting and fun it is, not just to get started using Microsoft Fabric, but to also solve business problems with it. Now it's time to replicate this and also learn more.